Hello, ladies and gentlemen, and right now we're going to talk about the ambiguous case of the sine law in solving triangles. Now, this situation occurs when we're given some information about a triangle. Just because you're given information about a triangle doesn't necessarily mean that the triangle exists, unfortunately, anymore. Sometimes they'll give us information about a triangle, and in fact, the information will not create a triangle, or, as in the case of the ambiguous case of the sine law, there's a possibility that it could create more than one triangle. And it's called ambiguous because we're not really sure which triangle they're talking about. So let's start off by talking about when this problem will occur. This problem will occur when you're given a angle measure within the triangle, a side length opposite that angle measure, so it has to be opposite, and a secondary side length. Now, it could have been here and it could have been here. It doesn't really matter. We can rotate the triangle around, and how we rotate it doesn't change anything. But what's important is that you have an angle measure given, a side length opposite it, and one of the other two sides are given. And that's all the information that you have. Now, notice that when you have a question like this, what you're going to use is you're going to go after this angle. You're going to go after that angle using the sine law. That's the most appropriate way of solving this triangle. In fact, it's the only way of solving this triangle. So you're going to have to go after the sine of angle B is going to equal, the sine of angle B divided by B is going to equal the sine of angle A divided by A. Now what's going to happen is this B is going to be moved up here, and you're going to get sine of B equals B sine A all divided by A. Now remember, these are all values that you're going to have. This value here is going to be there, this value here is going to be there, and this value here is going to go in here, and you use your calculator to get that decimal. What's going to happen is you're going to end up getting the sine of B equaling a decimal. Okay, there's going to be a number here, a decimal number. And that decimal number is going to be between 1 and -1. So it's going to go between, in fact, I could probably argue that it's going to be between 1 and 0 all the time, but I'll have to talk about that in a second. Let's think about the sine curve for a minute, shall we? The sine curve is going to look like this. And the sine curve is going to go up to a maximum. 1, 2, 3, 4. It's going to go up to 1, it's going to come down to -1. So it's going to go up to here, it's going to come to here, it's going to come down to a minimum, it's going to come back to here. So it's going to come up, it's going to come down, it's going to go down, it's going to come up. And this will be 1, this will be -1. We know that this is the sine curve. It's nothing new. We've seen it a whole bunch of times. Let's say I have a decimal here. Okay, and who knows what that decimal may be for different triangles and different information. It'll be a different decimal. Let's say perhaps that decimal happens to be 0.544. Okay, there's more numbers to that decimal, but let's say that that's our decimal number and that's what we're going to work with. So, working with that, I'm just going to do something here. Okay, so 0.54 would be approximately here. Coming across, we'll notice that we're going to have an answer for that here. Okay, and that answer, we know what this is, so we should probably point that out. This value here is 90. We know that because that's a critical interval of sine. That's going to be 180. That's going to be 270. And that's going to be 360. So we're going to get an answer that's going to be between 0 and 90 for sine of 0.54. And again, I invented that. Coming across here, we're going to get another answer. So there's going to be two answers for the sine of 0.54 that are going to be less than 180 degrees. Two of them. We need to make sure that our triangle takes both into account. Okay, so let's come back and look at that a little bit more closely. So what did we have? I came up with sine B equals 0.544. So we came up with that value. Let's work with this. So we're working with my calculator. I'm going to clear this. I'm going to do second function inverse of 0.544. And I'm going to get approximately 33 degrees. So angle B is equal to approximately 33 degrees. That's great, but we also know that if one of our answers is 33 degrees, Then our other answer, related acute angle, our other answer that goes with this is going to be 180 minus 33. So in other words, 180 minus my first answer. And that's what we're going to do in futures. We're going to make it easier just by taking our first answer and subtracting it by 180 to get our second answer. So that's your first answer. Or angle B could equal 180 minus 33, and in this case that would be 147 degrees. Now, what would matter at this point is, given our information, okay, what would matter is whether or not this plus our 33, okay, we would then get our C value. This angle up here would come from 180 minus what they gave us in angle A and minus what we came up with in angle B. Now, that's going to be what C is. So as long as, now if we think about this for a minute, as long as these two guys, as long as those guys don't come up with a value larger than 180, I'm going to have something left for C. So if the same is true for this angle, in other words, the secondary angle that I get for this, 147, will add to A, angle A, and as long as they don't add up to 180 or over, I'm going to have a little bit left over for an angle there. So there's a possibility of two different triangles having the same three pieces of information. They're very different triangles, but there's a possibility of two. That's going to occur when this angle here, which has two possibilities between 0 and 180 degrees, is able to make a third angle. Now, just to dovetail off that, there's no such thing as the ambiguous case of the cosine law. Let's take a look at why. The ambiguous case of the cosine law can't exist for a triangle because the interior angles of any triangle have to add up to 180 degrees. So what's happening with the cosine is that, and one of the worst cosine curves I think I've ever drawn in my life. But you'll notice that there's only one answer in between 0 and 90 degrees. The second positive answer for cosine lies out here after 270 degrees, which means that answer already is too large for a triangle. It's larger than 270 degrees, and a triangle must have its interior angles add up to 180 degrees if it's drawn on a flat surface. Okay, we'll stop there and I'll come back in a moment.